Spiral galaxy. A spiral galaxy is a flat, rotating disk of stars, gas, and dust wound into curved arms that trail out from a bright central bulge. The arms are not solid structures. They are waves of compression moving through the disk, squeezing gas into new stars, which is why the arms glow blue while the center glows old and yellow. Andromeda, the nearest large galaxy to our own, is a spiral. Roughly 2/3 of the large galaxies near us take this shape, which is why it is the picture most people have in mind when they hear the word galaxy. Barred spiral galaxy. In a barred spiral, the arms do not wind out from a round core. They start at the ends of a straight bar of stars that cuts across the center. The bar acts like a funnel, channeling gas inward toward the black hole at the middle, and often feeding bursts of star formation along the way. Our own Milky Way is one of these. We only work that out from the inside by mapping how stars and gas move, since we have never seen our galaxy from the outside. Elliptical galaxy. Ellipticals have no arms, no disk, and almost no structure at all. They are smooth clouds of stars, ranging from nearly spherical to stretched like an egg, and their stars orbit in every direction rather than turning together in a plane. Most of their gas was used up or stripped away long ago, so very few new stars are being born, and the population that remains is old and red. The largest galaxies known are giant ellipticals sitting at the centers of galaxy clusters, built up over billions of years by swallowing everything around them. Lenticular galaxy. A lenticular galaxy sits between the other two. It has the flat rotating disk and central bulge of a spiral, but the arms are gone, and so is most of the gas needed to make new stars. Seen edge on it looks like a lens, which is where the name comes from. Astronomers still argue about how they form. Some are probably spirals that ran out of gas and faded. Others may be the result of two galaxies merging into a smoother shape. Irregular galaxy. Irregular galaxies have no clean shape to classify. No arms, no bulge, no symmetry, just a rough scatter of stars and gas. Most are small, and many were pulled out of shape by the gravity of a larger neighbor. What they lack in structure, they make up for in gas, which means they are often still forming stars at a good rate. The Large Magellanic Cloud, visible to the naked eye from the southern hemisphere, is the best-known example. Dwarf galaxy. A dwarf galaxy holds anywhere from a few thousand to a few billion stars, against the several hundred billion in a galaxy like ours. They are faint and easy to miss, but they are also the most common galaxies in the universe by a wide margin. Current models suggest large galaxies grow mainly by absorbing them, one after another, over billions of years. The Milky Way is surrounded by dozens that we know of, and almost certainly more that are too dim to have been found yet. Satellite galaxy. A satellite galaxy is any galaxy bound by gravity to a larger one, orbiting it the way a moon orbits a planet. Most are dwarfs. The relationship is rarely gentle. The larger galaxy stretches its satellites over time, drawing out long streams of stars, and eventually pulls them apart entirely. The Sagittarius dwarf is being taken apart by the Milky Way right now, its stars smeared into a trail that wraps around our galaxy. Ring galaxy. A ring galaxy has a bright core surrounded by a distinct ring of stars, with a gap of near darkness in between. The leading explanation is a direct hit. When a smaller galaxy passes straight through the middle of a disk galaxy, the gravitational shock sends a wave of compressed gas rippling outward, and stars ignite along that expanding wave. Hoag's object is the classic case, a near-perfect ring of blue stars around a yellow core, and astronomers still cannot fully account for it. Peculiar galaxy. Peculiar is the label for galaxies that refuse to fit the standard categories: warped disks, twin cores, tails of stars flung out into empty space. Almost always the cause is gravity from something nearby, either a close pass or a merger already in progress. Halton Arp cataloged hundreds of these in the 1960s, and his atlas is still in use today. Peculiar is less a type than an admission that the galaxy has been recently disturbed. Interacting galaxy. When two galaxies pass close enough, gravity pulls both out of shape long before anything touches. Tidal forces drag out bridges of stars between them and long tails behind, and the gas clouds slam together and collapse into new stars. The antennae galaxies show this clearly. Two spirals mid-collision with two enormous curved tails. The stars themselves almost never hit each other. The distances are so vast that the galaxies pass through one another and eventually settle into a single larger galaxy. Starburst galaxy. A starburst galaxy is forming stars far faster than it can sustain, sometimes tens of times the normal rate. At that pace, it will burn through its entire gas supply in a small fraction of the galaxy's lifetime, so the phase is temporary. The usual trigger is a collision or a close pass that drives gas toward the center. Messier 82, often called the cigar galaxy, is the standard example, with superheated gas being blown out of its core in two great plumes. Active galaxy. In an active galaxy, the center outshines everything else in it. The source is the supermassive black hole at the core, which is feeding. Gas spiraling inward heats to millions of degrees and radiates enormous amounts of energy before it crosses the point of no return, and some of it is thrown back out as jets, traveling near the speed of light. Most galaxies, including ours, have a quiet, central black hole. Active galaxies are the ones currently being fed. Seyfert galaxy. Seyferts are active galaxies where the host is still clearly visible around the blazing core. Usually spirals, they show a small, intensely bright center against ordinary arms, which makes them useful for study, because astronomers can examine the black hole's behavior and the galaxy around it at the same time. Carl Seyfert identified them in 1943 by their unusual spectra, long before anyone understood that supermassive black holes were the cause. Radio galaxy. In visible light, a radio galaxy usually looks like an unremarkable elliptical. Observed at radio wavelengths, it becomes one of the largest structures in the universe. Two jets fire from the central black hole in opposite directions and end in vast lobes of glowing plasma that can stretch millions of light years, far beyond the galaxy that produced them. Cygnus A is the brightest example in our sky, and its lobes dwarf the galaxy sitting between them. Quasar. A quasar is an active galactic core at its most extreme, luminous enough to outshine every star in its host galaxy combined, and still be visible across most of the observable universe. When they were first found in the 1960s, they appeared as points of light with impossible spectra, which is where the name comes from, short for quasi-stellar radio source. Because the light takes so long to reach us, nearly all quasars we see belong to the early universe. They are what galaxies looked like when their black holes were still feeding hard.